Hi guys, we are starting section 2.6, rules for multiplication, and I'm going to begin by listing it's actually two rules or two properties for multiplication that you may see in this section. I'm not going to give them names because I don't think it's necessary, but if you take any number, you multiply it by 1, you're going to get the same number back. And you could write that in the reverse. So 1 times A equals A. You could also take a real number and multiply it by 0. That will always give you 0. And the commutative form of that, 0 times any real number, is 0. So I believe the top one is like the multiplicative identity property, and I think the bottom one is the multiplication property of 0 or something, but you don't need to know the names. Now, let's review the simple multiplication sign rules. Which we've learned this year earlier. All right, and so if you have a negative number times a positive number, that's going to be a negative number, right? That's all this says. It just says a negative times a positive is going to be a negative answer. Or a positive times a negative will also be a negative answer. Right? It doesn't matter which of the two numbers is negative. So we talked about that negative sign as being kind of like a stick. So if you have one stick, then it's going to carry through to the answer because it's like a negative sign. You're not canceling it, so it carries through to the answer. But if you have a negative times a negative, that's going to equal a positive, because those negative signs, if you take two of them, like little sticks, they can come together and cancel each other out and make a plus sign. All right, so those rules aren't anything new. What we're going to do is expand on that and broaden this rule a little bit. And so I'm going to give you the big multiplication sign rule. Big or rules, because there's really two of them. And I'm going to write, this is really important and very handy too. Important. Put a bunch of stars around it. All right. So, it goes like, let me see if I can slide this. Hang on for a second. I gotta move this thing out of the way. Slide this up. Oh, there we go. Okay. So there's two parts to it. Part one is that an even number of negative signs makes a positive answer. And part two an odd number of negative signs makes, as you guessed, a negative answer. So this means you can just count the number of negative signs in the problem and determine whether your answer is positive or negative. I'm going to circle this. I'm going to highlight it. But you have to understand there's some basic assumptions that have to be true. So you have to know the givens in this situation. This is only true for problems with all multiplication or division. Works for division too, because we haven't seen this yet, but division is really multiplication. You're really multiplying by a reciprocal. So we're lumping division in with this. If you have any addition and subtraction in a problem, this rule doesn't hold anymore. But if you have all multiplication and division, maybe it's all multiplication or all division or a combination of the two, then this rule applies. All right, so let's see what this means. So let's just work some examples. And I think you've done a little bit with this in the first section of chapter 2. All right, let's start with something easy. 2 negative numbers. Well, that's an even number. We know 2 negatives makes a positive, but you could also think of it as being an even number of negatives, right? For every 2, they're going to cancel and make a plus sign. So that's going to be a positive 12. All right, let's add some more numbers to the list. So -1 times 7 times -2 times -3. 4 numbers this time. So I'm not going to even look at these negative signs. When I multiply, I'm going to ignore them for the minute. And I'll figure out at the end what the sign's going to be. So 1 times 7 is 7, times 2 is 14. 14 times 3 is 42. Now there's 1, 2, 3 negative signs. That's an odd number, and therefore my answer has to be negative. And it makes sense because for every 2, right, these 2 are going to cancel each other out and make a positive. There's 1 left over. An odd number will always have an extra negative left over. If you pair up all the pairs, there will always be an extra negative, and that's going to carry over to the answer. All right, now you might throw some letters in with it, doesn't matter. 3y, 4z. Okay. And I usually look at the negative first, and I figure it out first, then I look at the numbers. So scanning the whole problem for negatives, I see 1. 1 is an odd number, so my answer will be negative. And then I look at the rest of the stuff. 2 times 3 is 6, times 4 is 24. X, Y, Z gets stuck at the end, no more parentheses. And that's the answer. So pretty easy, right? So this is an odd, this is even number negs. This is an odd number of negs, and also an odd number of negs. So it's a little easier just to count the number of negative signs and then figure out the sign of your answer. Okay, now slightly different kind of problem here. I'm going to slide over. -5 y minus 2d. Last section we did the distributive property, and you're going to see that again, except on last section you didn't have negatives on the outside, so that's the only difference here. But notice that we have a subtraction sign in here. which when I keep change, change will become an addition sign. These two rules only work if it's all multiplication and division. So I can't use the even odd rule to figure the sign of my answer here because I have a plus sign. But I'm just going to distribute and use my basic sign rules at each individual step. So, right, this is distribute. Different from these because of this plus sign in the parenthesis. So negative 5 times y is negative 5y plus negative 5 times negative 2d. At that step, we're multiplying two negatives, so that's going to be positive 10d. It's easy, but it's also easy to make errors if you're not careful. Okay, let's do negative 3 plus 6x. Now, the negative sign might be at the end. Sometimes they put it in a parenthesis. This one was not in a parenthesis. I think they're just trying to mix up the symbols and make sure you understand that it's meaning the same thing. Now, I can distribute it this direction, doesn't matter. But the point is, this is distributing, because there's a plus sign in here. So I'm not using these rules like I could with these first three examples. So negative 2 times negative 3, positive 6, plus negative 2 times 6x, negative 12x. And note, those are not like terms, just like these. These cannot be added to each other. So this would be the answer. And let's do, wow, I did not leave myself room for this long one. But this is the last example here. I'm sure you're heartbroken. 8t minus p plus 4, 2t minus 5p. Now we have two distributing steps. Make sure you keep change, change if you have subtraction. Right there, right there. Now we're going to carefully distribute, paying attention to the signs. 8 times t is 8t plus, be careful, don't put negative p, you have to distribute the 8 to that one too. 8 times negative p is negative 8p plus 4 times 2t is 8t plus 4 times negative 5p is negative 20p. Now, don't just stop and walk away because we have to add like terms. I have a t term and a t term here, a p term and a p term. And those like ones can add to each other. So 8 t's plus 8 more t's makes 16 t's plus negative 8 plus negative 20 p's, negative 28 p's. And actually, you know what? I know we're at 13 minutes. I really want to do one more, and I wonder if, okay, sorry, I'm going to do one more. Hopefully my phone won't die. I'm going to do one with a negative in the middle because I'm not positive if you're going to have one of these. So this is number 7. All right, let's make it negative 4x minus 3 minus 2x plus 1. So it's like the last problem, zoom in a little bit, except there's a minus in the middle. But I'm going to keep change, change here. This is subtraction, so you're going to keep change, change. Now, distribute the first piece. So negative 4x plus positive 12 plus negative 2x plus negative 2. All right, x term adds with x term, number adds with number. So I get negative 6x's plus 10. Now don't add those to each other because they're not like terms, and that would be my answer.